In this video, we will discuss in detail about I.E.Irodov problem 1.12. The problem states 3 points are located at the vertices of an equilateral triangle whose side equals A. They all start moving simultaneously with velocity v constant in modulus, with the first point heading continually for the second for the third, and the third for the first. How soon will the points converge? To solve the problem, let us first analyze the trajectory of the particles and the point where they would converge. We can argue that they would converge at the centroid using symmetry arguments. However, let us look at a more rigorous proof on the trajectory, and that they would converge at the centroid using some properties of equilateral triangles. Let ABC be an equilateral triangle and D, E and F be points on sides AB, BC and CA such that AD is equal to BE is equal to CF. Since triangle ABC is equilateral, all the sides are of equal length. Let the length of this side be equal to A. Therefore, we have AB is equal to BC is equal to CA is equal to A. Also, let AD is equal to BE is equal to CF, that is equal to X. Now, in triangles ADF and BDE and also CEF, we have AD is equal to BE is equal to CF, as that is how we have chosen the points D, E and F and assumed they are equal to X. AF is equal to BD is equal to CE, that is equal to A minus X. Angles DAF is equal to angle BED is equal to angle CFE. Since all of them are 60 degrees, as triangle ABC is equilateral, and therefore we have triangles ADF, BED and CFE are congruent to each other. Therefore, we have DE is equal to EF is equal to FD, or triangle DEF is equilateral as well. Now, let O be the centroid of equilateral triangle ABC. In triangles AOD, BOE and COF, we have AO is equal to BO is equal to CO. Since O is the centroid of equilateral triangle ABC, and for an equilateral triangle, O would be equidistant from A, B and C. Also, AD is equal to BE is equal to CF. Since that is how we have chosen the points D, E and F. Also, angle OAD is equal to angle OBE is equal to angle OCF, since all of them are 30 degrees. Therefore, triangles AOD, BOE and COF are congruent to each other, and therefore we have DO is equal to EO is equal to FO, and therefore O is also the centroid of the new equilateral triangle DEF. Let us now use this result to analyze the trajectory of points A, B and C. Initially, the points are located at A, B and C and are moving towards each other. That is, the velocity of A is directed along line AB, the velocity of B is directed along BC, and velocity of C is directed along CA. After a very small time delta t, their positions would be at A1, B1 and C1 respectively. Since the magnitude of the velocities are same, in a small time delta t, they would cover equal distances. That is, A1 would be equal to the length of BB1 and that would be equal to CC1. Using a previous result, we can now say that the new triangle A1, B1, C1 is also equilateral and that its centroid is still the same as the centroid of the original triangle ABC. Now, the point located at A1 would change direction and move towards point B1. Point B1 would change direction and move towards C1, and point C1 would change direction and move towards A1. In other words, point located at A1 would have its velocity vector in the direction of A1 B1 and would move along line A1 B1. Likewise, point B1 would have its velocity vector along line B1 C1 and would move along B1 C1, and point C1 would likewise move along C1 A1. Again, after time delta t, the new positions would be at A2, B2 and C2. And since the magnitude of the velocities are again equal, we would have A1 A2 is equal to B1 B2 is equal to C1 C2. And the new positions A2, B2 and C2 would form a new equilateral triangle whose centroid would again be the same as the centroid of triangle A1, B1, C1, which is the same as the centroid of the original triangle ABC. Now, by similar argument, the new points A2, B2 and C2 would move along A2, B2, B2, C2 and C2, A2 respectively, and the new positions after time delta t would be at points A3, B3 and C3 respectively, which would again form an equilateral triangle whose centroid is the same as the original triangle ABC. And again, after time delta t, the new positions of the point would be A4, B4 and C4, which would also be equilateral and the centroid would remain the same. Thus, we see as time increases, a new equilateral triangle is formed around the centroid of ABC, but the distance between the points, that is the lengths of the triangles, keeps on decreasing. In the limiting case, just before the points converge, the points AN, BN and CN would still form an equilateral triangle whose centroid is the same as the triangle ABC, and the lengths of the sides AN, BN, BN, CN and CN, AN would tend to 0. Therefore, the points would converge at the centroid of the triangle ABC. Now, let us try to solve this problem. We have seen that at any point of time, the velocities of the points are directed towards each other. This means velocity of B is V in the direction of C, and the velocity of C is V in the direction of A. Also, the component of the velocity of C in the direction of B is V cos 60 degree. Therefore, at any point of time, the relative velocity of approach of points B and C would be V plus V cos 60 degree, or 3V by 2, since cos 60 degrees is half. The initial separation between the points is A, and the time to converge would be their initial separation divided by their relative velocity of approach, or A divided by 3V by 2 or 2A by 3V. Now, we have also seen that as the points move, the centroid of the triangle created by the points A, B and C do not change. Therefore, at any point of time, the component of velocity of a point, say point B, in the direction of centroid does not change, and it is fixed, and it is equal to V cos 30. So the time to converge would be the time it takes for the point to travel the distance BO with a velocity V cos 30 degrees. From geometry, we know that BD is equal to root 3 by 2 A, and that point O divides BD in the ratio 2:1. Therefore, BO would be equal to A by root 3. Also, component of velocity of B in the direction of BO is V cos 30 degrees or root 3V by 2. Therefore, the time taken by point B to reach the centroid would be 1 by root 3A divided by root 3V by 2 or 2A by 3V, or the points would converge after time 2A by 3V.